Hello everyone. Welcome to Near Creation. Myself Niren sir. So today in this lecture I am going to discuss some 1 marks question of your previous year final exams. So I have select two different papers 2013 and another is 2015. In both the papers I will select all the 1 marks questions and I will try to explain all the necessary steps which will be required to find out the answer of each and every 1 marks question. So first I have selected 2013 paper. Okay. So here in this chapter, in this paper actually, the first question is this one. Okay. The question is this one as R is a relation on Z set of integers. Okay. The relation is defined on the set of integers. That means in the relation, what is relation? Relation is a collection of ordered pair. Okay. Relation means collection of ordered pair, but all the ordered pairs will be there in this relation which will satisfy this condition. What is the condition? Their difference should be divided by 3. All those ordered pairs will be there. Suppose if I will ask you, first of all, A and B should be integers because R is defined on the set of integers. What is relation? Relation means subset of the Cartesian product. R is defined on Z. That means R is a subset of Z cross Z. Okay. So that means whatever may be the ordered pairs will be there in R, the first element belongs to the set of integers as well as the second element is also belongs to the set of integers. That means A and B are integers. Now you will consider all those pairs where their difference will be divided by 3. Now it is 1 marks question. It is already given it is equivalence relation. That means the relation R is reflexive, symmetric as well as transitive. All the conditions are satisfied by them. Now the question is that what is the number of partition of Z? That means how many partitions will be there. Partition means what? Partition, the set of integers is given. Okay, suppose this is a set of integers. Partition means totally disjoint parts. Okay, how many disjoint parts are there? How many disjoint sets are there on the set of integers such that they are mutually disjoint? That means their intersection will be equal to 5 and their union will be equal to the whole set of integer set. Okay, so now we have to find it out how many partitions will be there. So first of all, we are going to explain what is partition actually. Partition itself is a set. Okay, partition itself is a set. So first, let us try to consider what is actually partition. Okay. So partition means, let us explain this question. This one. So here the relation are already you have gone through this what question. This is the relation. Okay. So in this relation, okay, R is a relation on Z. So first of all, we are going to explain equivalence class. Equivalence class of 1 means what? Equivalence class of 1 means what? It is a set which contains all those elements X. It will contains all those elements X which are related to 1. That means in this set, you have to find out all those elements which are related to 1. 1 or longer related means their difference should be divisible by 3. Related to 1 means what? What is the relation in this? What is the main condition in this relation? Their difference should be divided by 3. Divisible by 3 actually. Their difference will be divisible by 3. Related to 1 means you have to find out all those elements which are related to 1 means their difference with 1 will be divisible by 3. So in place of X, what you can put? Remember, both of them should be integers. Whenever you have to find out the equivalence class of any number, okay, whenever you have to find out the equivalence class of any number, then what you have to do? Always remember, in place of this two integer or two symbol, you have to put that number always. Suppose equivalence class of 1 means out of these two symbol, 1 should be considered as 1. Suppose in place of A, I have written 1 and whatever maybe the value of B will be here, it will be an element of this set. So writing in place of X, you can consider 1 because 1 minus 1 will become 0 and 0 will be divisible by 3. Similarly, in place of X, you can consider 4. Do you know why? Because 1 minus 4 will be minus 3 and minus 3 will be divisible by 3. Similarly, in place of x, you can consider 7 also, because 1 minus 7 is equal to minus 6, and minus 6 will be divisible by 3. In this way, I have considered all those values of x which are related to 1. That means the difference of x which 1 will be divisible by 3. So in this way, equivalence class of 2 means what? Equivalence class of 2 means what? It is a set. It is a set of all the integers which are related to 2. Equivalence class of 2 means you have to write down all those integers which are related to 2, means whose difference which 2 will be divisible by 3. So in place of x, what you can consider? So in place of x, you can consider, I think, 2, because 2 minus 2 will become 0 and 0 will be divisible by 3. Similarly, in place of x, you can consider 5, because 2 minus 5 will be minus 3 and minus 3 will be divisible by 3. In this way, I have considered all the possible integers which can be put in place of x, and all the elements are related to 2. Do you know why? Because the difference of all those integers from 2 will be divisible by 3. In this way, you can easily find out the equivalence class of 3. Okay, equivalence class of 3 is the set which contains all those elements like that: minus 6, minus 3, 0, 3. In this way. Listen, now equivalence class of 4. What you have got equivalence class of 4? In equivalence class of 4, you have got the set as like that. Okay, here dotted symbol sign should be there. Okay, dotted sign symbol should be there. Okay, so now listen, equivalence class of 4 means what? You have to find out all those numbers which are related to 4. That means whose difference from 4 will be divisible by 3. So in place of x, what you can consider? 4, 7, 10, like that. Remember, divisible by 3 na? So their difference should be same. 4 plus 3, 7, 7 plus 3, 10, like that. But if you compare equivalence class of 4 and equivalence class of 2 are same, am I correct? Just compare. What are the elements? 1. What are elements? 1, 4, 7, 10, like that. So here also you will have equivalence class of 4, 1, 1, 4, 7, 10, like that. That means we have got that equivalence classes will be repeated. Am I correct? Equivalence classes will be repeated. That means in a set you have infinite number of equivalence classes. But how many disjoint equivalence classes you will have? So after a finite interval, it will repeat. That means you have got equivalence class of 1, equivalence class of 2, equivalence class of 3. After 3, equivalence class of 4 is exactly equal to equivalence class of 1. Equivalence 2 will be, equivalence class of 2 will be equal with equivalence class of 5. Equivalence class of 3 will be related to equivalence or equal with equivalence class of 6, like that. So in this way, you have infinite number of equivalence classes. But remember, how many disjoint equivalence classes you have actually? We have exactly 3 disjoint equivalence classes, and number of disjoint equivalence classes is known as partition. So how many partitions we have exactly? That means we have divided the whole set of integers into exactly how many parts? 3 parts. Okay, 3 equivalence classes are there. Exactly 3. Equivalence class of 1, equivalence class of 2, then here equivalence class of 3. Their union become a whole set of integers and they are mutually disjoint. Okay, but you cannot consider equivalence class of, in place of 3, you cannot consider equivalence class of 4, because equivalence class of 4 and equivalence class of 1 are same. You have to consider only disjoint. You will have exactly 3 disjoint equivalence classes. You can consider like that also. 3 parts. Equivalence class of 4, then equivalence class of 5, then equivalence class of 6. Because equivalence class of 4 is same as equivalence class of 1, equivalence class of 5 is same as equivalence class of 2, and equivalence class of 6 is same as equivalence class of 3. Got it? So how many equivalence classes you have? 3, and exactly disjoint number of disjoint equivalence classes is known as partition. So how many partitions we have in this case? So we have exactly 3 different partitions. So what is the answer then? So here in this case, we have the answer is, okay, here in this case, we have the answer as, 3. We have 3 partitions. Okay, so let's next question. Write down the domain of cosec inverse function. So it is known to you, cosec inverse function. Generally, what is the domain of sine inverse? The domain of sine inverse is, I think it is known to you. Domain of sine inverse is this one. Close interval minus 1 comma 1. This is the domain of sine inverse as well as cos inverse. What is the domain of cosec inverse? Cosec inverse is That means cosec is the reciprocal of sine. Therefore, its domain is real number minus open interval minus 1 comma 1. Generally, what is the domain of sec inverse? Sec is the reciprocal of cos. That's why it will be real number. That means same, open interval minus 1 comma 1. In this way, that means what is the domain of cosec inverse? Cosec inverse, cosec is the reciprocal of sine, so it will be real number minus open interval minus 1 comma 1. What is the domain of sec inverse? Same. Okay, so in this way you have to find out, correct? Next question. What is the third one? If A is a square matrix of order 3 such that A is a matrix of order 3, that means we can say that A is a matrix of order 3 means, okay, it is a 3 by 3 matrix. Okay, and it is given that adjoint of a determinant of adjoint of A equal to 36, then you have to find out the value of determinant of A transpose. We know that determinant of, okay, we know that determinant of, okay, actually this one is like that. Okay, actually here what is given to us here in this case, so here A is a 3 by 3 matrix. A is a 3 by 3 matrix, and it is given that determinant of adjoint of A is equal to 36. Okay, it is already given. So one relation is there. Determinant of adjoint of A is equal to determinant of A whole to the power n minus 1. What is n? N is the order of the matrix. That means we can easily write down determinant of adjoint of A is equal to A determinant of A whole square, because A is a matrix of order 3. So in place of 3, in place of n, you have to write down 3. So 3 minus 2 is equal to 1. But determinant of adjoint of A is equal to what it is given? 36 it is given to us. That means you can easily write down it will be 36. Okay, so it will be 36 and determinant of A whole square. Correct? So determinant of A will be equal to what? Determinant of A will be equal to plus minus 6. Am I correct? Determinant of A square is equal to 36. So determinant of A is equal to plus minus 6. It is not modulus. It is determinant. So determinant may be positive or may be negative. If determinant of A is equal to plus minus 6, then what is the value of determinant of A transpose? It is known to you. One another property is there. Determinant of A is always equal to determinant of A transpose. Am I correct? One formula is that determinant of A is always equal to determinant of A transpose. That's why whatever may be the value of determinant of A, it will be the value of determinant of A transpose. Somewhere you will have A t power t or A dash, A prime. Then that's why using this property, we can easily write down determinant of A transpose equal to plus minus 6. Am I correct? Because determinant of A is always equal to determinant of A transpose. That's why what is the answer? Plus minus 6. Here in this case, we have applied two different formulas. First of all, determinant of adjoint of A equal to determinant of A whole to the power n minus 1. What is n? N is the order of the matrix. So here, what is the order of the matrix? 3. So in place of n, I have written 3. So 3 minus 1 is equal to 2. But determinant of adjoint of A is equal to 36. It is already given. So after having the simplification, we have got determinant of A equal to plus minus 6. But you have to find out the value of determinant of A transpose. So how can you find it out? Determinant of A is always equal to determinant of A transpose. That's why determinant of A transpose is equal to plus minus 6. You have got it. Okay. So generally, what is the answer we have got here? The answer is plus minus 6 is the answer. Okay. So next question. See. So next question is what? Next question is very simple. A is given. A is given as a 1 by 1 matrix. Okay. A is given as a 1 by 1 matrix. Now you have to find out the determinant of A. So let us consider another example. Then it will be easier for you. Suppose A is equal to matrix of 1. Then what is the determinant of A? Then determinant of A is equal to determinant of 1, and determinant of 1 is equal to 1 always. Am I correct? That means in case of 1 by 1 matrix, the determinant itself the element. Determinant the element is same. The determinant value is nothing but the element itself. In case of a 1 by 1 matrix, 1 by 1 matrix, only one row and one column will be there. So here in this case also, so A is equal to matrix of 5 plus I. So determinant of A is equal to what? Determinant of A is equal to just like as this one only. Just like as this one. Determinant of 5 plus I. This is not modulus. This is a complex number, no doubt, but it's not modulus. So that you are not supposed to find out square root of 5 square plus 1 square. It's not like that. Okay. So determinant you have to find it out. Determinant the element itself. So 5 plus I. Correct. So the answer is 5 plus I. A is a matrix, 1 by 1 matrix. So determinant of A is equal to the element itself. Whatever it may be positive or it may. Suppose if A is equal to matrix of minus, suppose minus 5. Then here in this case, what is the determinant of A? Here in this case, determinant of A is equal to determinant of minus 5 is equal to minus 5. Correct? So you are not supposed to send a sign. Determinant means the element itself in case of 1 by 1 matrix. Okay. It is not modulus, so that it will become positive. It is a determinant. That's why the element will remain same. So what is the answer then? So we have got the answer is, we have got here, the answer is 5 plus I. This is the answer. Correct? So next one. So what is given here? Omega is the cube root of unity. Omega is the cube root of unity. Okay. So omega is a cube root. So what is the condition for cube root? If omega is a cube root of 1, that means we have omega cube is equal to 1. And next one is 1 plus omega square equal to 0. Am I correct? So these two conditions are satisfied by omega here in this case. Now what you have to do, you have to find out what is the value of the one root of the equation. Here you have to find out this is the equation, obviously. Why? Left hand and as well as right hand sides are given, and see, you have to simplify so that you will have the value of x using these two conditions. Remember, behind the screen, omega cube is equal to 1 because omega is a cube root. So 1 plus omega square is also equal to 0. Now we'll try to simplify, and after having the simplification, we'll try to find out the root. Okay, so let us try to simplify. So we can easily apply the property. Correct? So which property? If you observe carefully, then you will observe that the elements are same, just their positions are different. 1 x omega square, omega 1 x omega square, 1 x omega square. So that means in the same way, in according to column wise also, x 1 omega square, omega x omega square 1 omega square 1 x omega. So you can easily apply any property, add all the rows or all the columns. So I will try to apply all the rows here. Correct? So suppose all the columns. So I am going to apply this property. So this one, column 1 tends to column 1 plus column 2 plus column 3. Column 1 tends to column 1 plus column 2 plus column 3. That means I am going to add these elements like that. This one plus this one in this way. Okay. So what is the first? That means the first elements will be 1 plus x plus omega square. Correct? Second element is 1 plus omega square plus x. 1 plus omega square plus x. Correct? So others will be remain same. The second next elements will be remain same. So if you observe carefully, then you will get my point. 1 plus omega square equal to 0 according to omega cube root property. Cube root property, 1 plus omega square equal to 0. So sum of these three term will become 0. So x will be remain in the first column. So the first elements will be x. It will be omega 1 plus omega square 1 x plus omega. correct, is equal to 0. Okay, now what you do, you can take x common outside, so we'll have x, then 1 1 1, it will be omega 1 plus omega square, correct. Next one is, oh sorry, x plus omega, next one is 1, then it will be omega square 1 x plus omega, am I correct? So equal to 0 already given, correct. Again you can simplify, that means you can make these two element equal to 0, and after making these two element is equal to 0, and you have to expand it and you have to find a value, correct. What are the procedure I'm just going to explain. First of all, you have to apply any property, either you can use row operation or column operation. So I have applied column operation. After applying the column operation, the first elements of the elements of the column, first column will become 1 plus omega square plus x, in this way, because 1 plus omega square equal to 0, the first elements will be x x x, then you can take x common, so it will become 1 1 1. That means you have to make these two elements equal to 0. How can you make it 0? By applying row 2 minus row 1, row 3 minus row 1. So these two elements will become 0, and you have to then expand with respect to this element, expand it, and you'll have the answer, correct. I hope you have got my point, correct. Okay. So next question is that x minus, what is the equation of the normal at the point? Normal at the point x naught comma y naught if dy dx at this point does not exist. Generally, equation of normal means what? Equation of normal means, what? Y minus y naught is equal to minus 1 by dy by dx into x minus x naught. Am I correct? So this is the equation of normal, but it is given that dy dx is not defined. That means this one is not defined. So something 1 by not defined is equal to 0. That means this term will become 0. Am I correct? Suppose let us consider not defined is infinity. So 1 by infinity will become 0. Correct? 1 by infinity will become 0. It is does not exist. Does not mean dy dx does not exist means 1 by not defined is equal to this term, whole term will become 0. If this term will become 0, 0 into something will become 0, then we will have y minus y naught is equal to, that means we have y minus y naught is equal to 0. This one implies y is equal to y naught. First of all, we have to write down the equation of normal. It is given dy dx does not exist. That means 1 by dy dx equal to become, this one is infinity. So 1 by infinity, it will become 0. So 0 into something, it will become, the right hand side totally become 0. Then we will have y minus y naught is equal to 0. This one implies y equal to y naught. So in this way, you have to find it out. Okay. Next question. So what you have got actually? So here in this case, we have got that y minus y naught is equal to 0, or you can write down y is equal to y naught. Correct? So next one. So what is the value of ddx of greatest integer of x? If x lies between 6 to 7, obviously we will have the greatest, the derivative of greatest integer does not exist at integral points. At integral points, derivative does not exist of greatest integer function. But here you have to find out a derivative of greatest integer function at all non-integral points. Got it? Because in between 6 and 7, all the non-integral points are there, which are only decimal points are there. And in decimal points or non-integral points, greatest integer function, the derivative of greatest integer function exists, and it will become 0. Or in shortcut way, you can think about like that. That means if we consider any decimal point, it lies between 6 and 7, it will become what? Suppose 6.7. Let us consider 6.2. ddx of shortcut way. Okay, this is not the correct procedure. 6 point, suppose you have to find out at 6.2. What is the greatest integer value of 6.2? is equal to 6, and ddx of 6 is equal to what? It will become 0. But remember, at integral points, get is the function, the derivative does not exist. At integral point, derivative of get is the function does not exist. So here, what is the answer? Answer will become 0. That means the answer is 0 here. Okay, here in this case, answer is 0. Okay, so what is the answer here? We have answer is equal to, here answer is 0. So let us consider another one. What is the projection vector of A along B? Projection, generally the projection of A along B is equal to, okay, A dot B, A vector dot B vector divided by magnitude of B. Remember, projection of A along B, projection of A along B, that means B will be there in the denominator. But here you have to write down projection vector. This is scalar quantity because dot product itself is a scalar quantity, as well as magnitude also is scalar quantity. So that means the whole quantity is a scalar quantity. To be vector, we know that 2 is a scalar quantity. To be vector, either I cap should be there, j cap should be there, or k cap should be there. That means you have to multiply it by a unit vector. So the unit vector will imply its direction. So 2 cap means it is along the x-axis. That means x direction. It is along the, is j cap means it is along the y-axis, and k cap means it is along the z-axis. So it is along what? It is along b vector. B vector means, so you have to write down the unit vector of b. K cap means what? It is along the z-axis. So k cap is nothing but the unit vector along the z-axis. So that's why it is a vector quantity. Initially 2 is a scalar quantity. To be a vector quantity, unit vector should be written. It will give us a direction. So as it is, you have to write down the projection vector. That means one unit vector should be there in the nearby. So the unit vector of A or B, it is along B vector. That means along the B direction. So you have to represent the B direction, you have to write down the unit vector of B. So projection vector of B along A, this one is, expression will be A dot B divided by magnitude of A. No doubt, this is a projection only. So projection vector along B means A vector should be there, A cap should be there. This is scalar quantity into unit vector. So this is a vector quantity. So what is the answer here? A dot B divided by magnitude of B into B cap. It is the projection vector of A along B. Correct? So next one. Okay. So what is the next one? Next one is this one. What is the distance of this point from z-axis? We have the idea. How can we find out the distance between any 2 points? The formula is square root of, what is the formula? Square root of, it is known to you, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the formula to find out the distance between any point in 3-dimensional plane. In 2-dimensional plane, you have to apply, you have to consider only 2 components. Okay, but as you have to find out the distance of this point from z-axis, what you will do, suppose, let us consider for a time being, for simplification purpose only, we'll consider, suppose one point is given, whose coordinate is 1, 2, 3. Okay, suppose you have to find out the distance of this point from x-axis. This is x-axis. If you want to find out the distance of this point from the x-axis, we'll consider this point on the x-axis. So in x-axis, y and z coordinate will become 0. That means its corresponding point will be what? 1, 0, 0. In x-axis, y and z component will become 0. Distance of this point from this point and distance of this point from the x-axis will remain same. That's why whenever you have to find out the distance of a point from any axis, from any plane or any line, you have to imagine this point on that line, on that plane. So here, as this one is x-axis, so we are going to consider this point on the x-axis 1, 0, 0, because in x-axis, y and z component will become 0. We are going to find out this distance of this point. Obviously, x2 minus x1, y2 minus 1, z2 minus z1. Correct? Suppose if you have to find out the suppose this one is z-axis. Let us consider. So you have to find out the distance of this point from z-axis. Then we will consider this point on z-axis. So what is the coordinate of this point? 1 comma, oh sorry, in z-axis y and z coordinate, y and x coordinate will become 0 and z coordinate will be there. That means distance between these 2 points and distance between this point and z-axis will be remain same. So answer will be, so here in this case, if we'll consider this point on which axis? Z-axis. So on z-axis, then the point will be in z-axis, only z component will be there. X and y coordinate will become 0. That means we have to find out the distance between those 2 points. X2 minus x1, y2 minus y1, z2 minus z1. So what will be the answer? Let us try to calculate. X2 minus x1 means 1 minus 0 whole square plus minus 2 minus 0 whole square plus 3 minus 3 whole square. Correct? So what is the answer then? It will be 1 square. 1 plus 4. Okay, square root of 5 is the answer. Correct? So that is simplify. That means moral of the story is that whenever you have to find out the distance of any point from any plane or any axis, just consider this point on that plane or on that axis. Correct. So suppose you have to find out the distance of this point from the YZ plane. YZ plane. But let us consider YZ plane. In YZ plane, Y and Z coordinate will be there. X coordinate will become 0. In YZ plane, X and Z coordinate will be there. Sorry, X coordinate will become 0 and Y and Z coordinate will be. What is the Y coordinate? Minus 2. And what is the Z coordinate? 3. That means you have to find out distance between these 2 points. Okay, in YZ plane, X coordinate will become 0, Y and Z component will be there. So the corresponding point is this one. Try to find out this distance between these 2 points. You will have the answer. So here in this case, what we have got? Here in this case, we have got here in this case we have got, okay, the answer is equal to, okay, root 5. Next question. Okay, what is the next question? Okay. Can a vector have direction angles as 45 degree, 60 degree, and 120 degree? Can a vector have direction angles as 45 degree, 60 degree, 120 degree? Direction angles means what? Direction cosines. Okay, direction cosines. To be direction cosines, what is the condition to be satisfied? L square plus m square plus n square should be equal to 1 to be direction cosine. So let us try to, they are direction angles. We'll try to find out the direction cosines. Direction cosine means cos of 45 degree. Cos of 45 degree plus cos of 60 degree, we have to find it out. Okay, then we are going to find out cos of 120 degree. Correct? So all those values we are going to find it out. Okay, so then it will become their direction angles actually. So if we'll have the cos values of this one, then will become direction cosines. So cos 45 degrees is equal to 1 by root 2. Cos 60 degrees is equal to half, and cos 120 degrees is equal to minus half. Okay, now to be direction cosines, we are trying to find it out. They are direction cosines or not actually. To be direction angles means their direction cosine, they will form a direction cosines or not. To be direction cosines, their square should be equal to 1, sum of their squares. So 1 by root 2 whole square plus half of whole square plus minus half of whole square. Try to simplify. So it will be 1 by 2 plus 1 by 4 plus 1 by 4. So what is the answer? 4, 2 plus 1 plus 1. So answer is 4 by 4, which is equal to 1. That means as the sum of their squares is equal to 1, that means they can form a direction angles. Remember, direction angles means their direction angles. Okay, so can you consider their inclinations? So first of all, we have to consider direction. Angles are given, so we have to find out the direction cosines. To be direction cosines, three values will be known as direction cosines if the sum of their squares is equal to 1. So let us try to find out their cos values. Direction cosines, cos values. Cos 45 degree 1 by root 2, cos 60 half, cos 120 minus half. So if the sum of their squares is equal to 1, that means then obviously they can form a direction cosines or direction angles. So sum of their squares is equal to 1. That means we have got that they can form a direction angles. So I hope you have got the basic ideas about how can you find out the answer of each and every question of 1 marks of 2013 paper.